I will hand over straight to our moderator for this panel to introduce our speakers. But as you can see on the screen there, we're talking all about artificial intelligence in FinTech, particularly the ethic and bias lenses. So welcome to the panel.
Thank you very much. And as I said, please move in the front of the room because we can have an intimate discussion straight after lunch. Welcome to the AI in FinTech Ethic and Bias Lens discussion. I'm very excited to lead this discussion on the ethic and biased aspects of the rapidly integrated machine learning, AI functions and models used in FinTech and banking. My name is Linda Staniewicz. I'm the Chief Strategy and Marketing Officer for Emergent Payments Asia. Before we dive into the topic areas, I'd like to welcome my amazing panel here today. Starting from the end, Flora. She's a professor and Cisco Chair of Digital Transport and AI, University of New South Wales. She's done a lot of research in human-centric AI and machine learning. We got Nicholas, who runs a machine learning business. We have Gulshan, Executive Manager, Payments and Policy Advocacy from CBA. And Harm, who's the Director of Virtual Inc. Australia, advising government and corporation regarding AI bias prevention and AI standards. So please welcome the panel. Thank you. So crafting AI models with ethical considerations is commendable, yet the domain of ethics is complex and deeply rooted in diverse culture perspectives. So how do we define what is ethical in an AI model? What are some of the key ethical concerns when it comes to applying AI models in banking and FinTech? Flora, would you like to start on that one?
All right, thank you for letting me to kick off. So first of all, how many of you here believe that your day-to-day life has been somewhat influenced by an AI system? Yes, great. Thank you. Well, how many of you come here this morning and use Google Maps? Right, so that's actually, you actually trusting a system with an underlying AI mechanism to get you here. And that's basically how AI is used, even in FinTech, because it's somewhat automating decision-making purposes. So it might be semi-automatic or fully automated, even in, for example, judging an outcome of a loan or things like that. And therefore, this is why ethical is important, because ethics, one of the basic tenets is, a Hippocratic oath, do no harm or do good. But if for someone who either design an AI system, or maybe some of you here might be the one who actually decide which system to deploy in your company, in FinTech, in a bank, in e-commerce, how would you ensure your system will be ethical in a way? And there are a lot of key principles around that. I won't go into much detail, but you can take a look. There's a lot of regulatory framework now about this surrounding transparency, trust, explainability, accountability, and also bias and fairness. I won't go into further detail, but let me just pass it on to Harm.
Thank you, Flora. Yes, you talked about systems, and another way of breaking down that challenge around deciding at which point you need to apply ethics is by thinking of use cases. And your Google Maps example, of course, is an example where the consequences of something going wrong are limited, although it's annoying if you end up on the wrong train or you end up taking a wrong turn. But overall, the consequences are limited. Thinking about the intent of the use case and the possible consequences actually helps shrinking down that question that seems to be sort of almost too overwhelming to contemplate. What is AI and what is ethics in AI? Bringing it down to something that you can approach in a far more piecemeal in a positive sense session is a good way to get started.
Yes.
And I think that's exactly the approach we use. So our approach is underpinned by, like as you mentioned, there's lots of different standards. So our approach is underpinned by the Australian AI ethics principles, which we were involved in developing and piloting in 2019, but we're also guided by our purpose. So we make sure that all our use cases are really grounded in cases that will benefit the customers and communities that we serve. So for example, we used AI to create Benefits Finder, which matches people with unclaimed government discounts or grants or benefits that they might have been unaware of. And since it was created, we've matched people up to $1 billion in unclaimed benefits.
Yeah, I think it's a very difficult question, as you said, Linda. And I think, being a new industry and everyone having their own opinions and the nomenclature being also kind of new, I like to kind of break it up into two different sections. So you've got ethical AI, which is often used interchangeably with responsible AI. But to me, they're quite a different concept. So ethics is an unsolved field. You've got tons of philosophers arguing about what's the right thing to do, utilitarians like Peter Singer, virtue ethicists, etc. And there's never broad agreement on exactly what is ethical. There's, general agreements on what the right thing to do is in certain situations, but overall it's very hard to get agreement. So I like to think of ethical AI as kind of like a philosophical complex problem that the people in academia have to solve. Responsible AI is probably more a practical solution, which is when a business has an idea of what they want to do, that's kind of like a contract between them and the public. We're not going to steal your data, we're not going to do invasive techniques, we're not going to treat you unfairly. That's when you can actually start to get groundwork done and actually create tools that benefit both the business and their consumers.
That's very good, thank you. So we got a lot of different answers to the same question. I think that's common for all of the fintechs out there. So from that, we know that we have studies that have used AI and discovered gender bias. It's the outcome of the algorithm application from natural language processing techniques. So how can fintech companies approach the issue of bias in AI model? So case studies, example, data set usage.
Would you like me to go first?
Yes.
All right. So there are emerging standards that help organizations investigate their data sets for bias. Bias is something that you can mathematically ascertain and prove, right? Now, when we talk about bias, most of the time the implied assumption is that bias is unwanted, right? That's not necessarily the case. We all use with algorithms, we tune the parameters, we tune the hyperparameters. We actually bias the system towards a particular outcome. That outcome is informed by the data set that underpins it. And again, we can, through tools like confusion matrices, determine the degree of bias in that data set. And you mentioned fairness before, right? So whilst bias is something that we can ascertain and prove, fairness sits much more in that discussion around, well, what is our purpose and how well does this application serve our purpose?
Yeah, it becomes very difficult when you're actually building the model, like you said, to determine what's the good bias and the bad bias. Because from a mathematical point of view, bias is actually what allows a model to run. If you don't have any bias in your data set, it's just a flat line that's not going to have any predictability or any use at all. And most of the time, bias actually exists in the data itself. So models don't really make mistakes. They're simply learning algorithms that just process data, run equations on them, and give you outputs. So if you've got biases, in your model, generally the best place to start is looking at data and essentially try and find ways to mitigate that, whether it be through synthetic data creation, manual curation, or tweaking certain things. And it's not quite as easy as just like removing the variables that are biased as well. Like, let's suppose you're building a model that determines whether someone should get a loan or not, and you're just like, no, I don't want gender to come into this at all. It shouldn't be a predictive feature. It shouldn't even be in it. So you just completely take the variable out of the model. Well, as long as you have other variables that correlate to variables you don't want, like let's say you have how much someone's net pay for a year, well, that's relatively somewhat correlated to gender. Add another 5 features in that are correlated to that, and suddenly gender's back in the model unintentionally. which is why, like Aram said, you need to use meta techniques like confusion matrices and stuff to actually determine whether a model is biased or not. You can't just look at what you're feeding in.
So bias and fairness is still a very difficult things to work out. I come from AI machine learning community, and so I think to date there are more than 40 evaluation metrics for example, one could be equal opportunity. You have subgroups in your population. Your subgroups could be gender. Your subgroups could be age, right? Could be even income brackets. But how do you ensure, for example, if only for one matrix, let's say equal opportunity, they will get an equal outcome if you have a balanced data set? There will be one. But there could be other metrics, for example, equal accuracy. What does it mean? Equal accuracy means, let's say loan application, whether someone will likely to be will be a defaulted or not, based on their history. How accurate is the model? If the model is highly accurate to predict the outcome for male, say 90%, but then for female 50%, that means your model's biased. That's an example. But that's only accuracy. There are a lot of other, the odds of someone getting picked out in a model. So I would say this is basically should be a multi-stakeholder conversation. Cannot just be reliant on the data scientists to decide what is the best metrics, because sometimes it's to do with the business outcome. So if you want a model to be biased, you might also even increase, the model to be more accurate and less risky. If you want to make it, there's a little bit of trade-off, utility and fairness. How do we get that balance of model still accurate and highly performing while also fair? That will be one. So it's very much a multi-stakeholder, multi-objective problem. And one good case study to mention as well, I like what you mentioned about proxy variables. Sometimes we say, okay, let's just remove gender, or let's just remove any of these potentially biased variables. But there's a lot of proxy variables, say suburb. We know someone living a certain postcode, what sort of underlying demography, right? And this happens all the time. Models that are trained on, having even those kind of information. You don't have exact address, you have postcodes. That model can still be biased towards certain demography. Yeah.
Thank you. So Gulshan, how do you look at this in terms of being a bank, looking at when you create your AI models in terms of inclusiveness and?
Yeah. So as we've said, data is fundamental, and we've got the privilege of having access to a lot of customer data. So we see 40% of all payments transactions in Australia, and we have 8 million digitally active customers. The other way we control for it is still the human element, so making sure that the teams that develop and implement AI are diverse themselves. So in general, as a workforce, we want the composition of our workforce to reflect the community and customers that we serve in terms of gender and cultural, but also in our AI teams having the diversity of experience. So we've got data scientists working with people who have frontline customer experience.
Nick.
Yeah, I actually saw a really good example of what Flora was just saying before, and why your class level accuracy is so important. You can't just rely on overall general accuracy metrics. So I read about an interesting case study in China where they were using facial recognition software to allow people to enter into their own apartments where they lived. And the data set, unsurprisingly, was trained on mostly Chinese people, which was perfectly okay for the cities and apartments where essentially all the residents were Chinese. But what happens is when you get to some of the more multicultural cities like Shanghai or Guangzhou, you get different types, different races of people. You get more white people living there, you get more black people living there, etc. And what they found was, even though the accuracy for this was like 99.99, for Chinese people, because that's what it was trained on. For any other class of people, the accuracy was closer to, 60, 70%. So you had a bunch of these people of different races being locked outside of their own apartments, not being able to get in the main gate because their facial recognition software wasn't trained, wasn't fit for purpose of what they were trying to do.
So that's a really interesting point. So on the aggregated level, it could be accurate, but in the segmented, it's not.
That's right. Yeah.
Just to add on one very quick case study, more general rather than related to FinTech, is a very famous case study on AI used for sorting CVs for job application. And it is even just by the way the cover letters are written and the resumes are written. If you just use if the bias is not accounted for, the model always rank the male CVs superior than the female. Even just the way it's written, because the tone of the cover letter is always a lot more confident, the male ones. So you end up getting shortlists all the time, majority are male. But if you actually inject understanding of this model can be biased, we need to do segmentation of the subgroup first. And we know, for example, these are the performance of the model against the male cohort or female cohort, and how do we balance that performance?
And one more example, I'm not quite sure he has a home assistant in their home, but in my experience, women find this incredibly difficult to use for the home assistant to understand them, and that's largely because the underlying data set again was mostly trained by male software engineers on their male counterparts, so it performs well for male speakers, but much poorer for female speakers. And I suppose we give you these examples to help you think about, well, what could be underpinning in my data set that makes me think about whether the algorithm delivers the kinds of outcomes that we're seeking to achieve.
Yeah, so all about having that diverse data set or manipulate to get it. I guess that's what you're saying. So diving in more to behavior understanding, what challenges arise when you're trying to understand, model human behavior using AI? Are there certain behaviors that AI finds especially challenging to predict or comprehend?
I'll go first. There's great interest in emotion detection, and there are many organizations out there that claim to understand or predict emotion based on facial expressions, whether there's certain physical characteristics possible in lie detection through certain aspects of the spoken language, and repeatedly we find that these claims tend to stand up reasonably well in the lab, but completely fail in the real world, and that's usually due to the overfitting of the data set to the test cases.
Right.
So that kind of behavior is very difficult. But then there are other things like gait recognition, for example, is a pretty good accurate biometric to identify or at least verify someone's identity. Right. So there are certain aspects that AI at the moment is pretty good at, and others that it is still very much a work in progress or potentially beyond the reach of AI.
So be interested to hear from your perspective, building these ML models.
Yeah, it's almost like a self-fulfilling prophecy, isn't it? Because, I mean, depending on who you ask, the definition of AI is somewhere along the lines of, a non-organic computer system trying to do human-like tasks, right? And turns out maths is a human-like task. We invented maths, and no one seems to think of calculators as AI because they're just significantly better at it than us. So we've almost like got this new broadly accepted human definition of AI at being like doing tasks that humans do that computers aren't really very good at and struggle with anyway. So most of AI kind of falls into that category. But I'd say a couple of times where AI really struggles compared to humans is with unstructured data. So the original machine learning models were all mostly from tabular data, so neatly structured, clearly articulated data. And now, as we move into the more generative AI use cases and the more hardcore use cases, things like speech, text, video analytics, sound, whatever, we find that AI is struggling with that even more. And I guess the last thing that is kind of still in process with things like ChatGPT and such, that we're not really sure how well AI is going to perform, is with pure creativity. Now, it's somewhat debatable whether humans even have real creativity or it's just like some aggregation of what they've experienced and learned through their life. But it's very clear where the AI, creativity comes from. It's all in the algorithm. We can see it. It's all just equations. So whether they can, create something truly new through generative AI, or whether they're just, merging things together, mishing things together, and that time will tell, I suppose.
Yeah, thanks for that. And Flora, I'm very interested to hear your perspective, having done so much research in this area.
Yeah, so human behavior is a loaded word, but let me just, and you asked another part of the question, which is, which part is easier for machine learning model? Which kind of data is harder? First, machine learning, a model, is trained on huge data, especially training data. And what does it mean? Training data means they are usually annotated, properly annotated, right? For example, one of the initial breakthrough in early 2010s on the deep learning is basically trained on ImageNet. And that's basically thousands of images properly labeled. But we as human, we can label them. You are shown a picture of a cat and a dog. You know which one is a cat, you know which one is a dog. Now think about other data sets that are more complex. Data coming from human behavior. As you sit right now, you have senses. You might be wearing a smartwatch like me, right? You're sitting here, and then you're moving around. That kind of behavior that is actually longitudinal, continuous. If you're not an expert in the field and you just see time series signals, sensors, you are asked to annotate that kind of data. It's very difficult. And therefore, people like me who do my research on machine learning on longitudinal time series sensor data for understanding human behavior, human mobility, health, anomalous behavior, even anomalous behavior either in within these buildings or in the city, is actually, we need to rely on new way of modeling that doesn't rely on labeled data. And this is what we call self-supervised learning. And in fact, this is the underlying mechanism of foundation model, which is now becoming something like GPT. It's actually trained on really large scale, unstructured, as you said, even unlabeled data. It's learning from its own signals. It's actually generating different kind of augmentation of the same data set, and to see whether this data set is, whether this part of the data is similar or not. And therefore, if we then can fine-tune that model into a certain task that is labeled, then we can reuse it for a specific domain, specific purpose. That's why something like GPT has become so powerful, because it's then it can be used for translation tasks, for predictive tasks, for retrieval tasks, and a lot of things. It cannot do forecasting tasks yet. That's what we're doing. We're doing GPT for forecasting, time series forecasting, so which is very relevant to FinTech. So this is why I'm saying that this kind of, when you have lots of data that are not labeled, that is actually quite difficult to work with.
For sure. So I think we also, in a pre-panel session, talked about sometimes it's better to have a small data set with really clean data, and you can get an accurate model rather than have the big data set, which has been the focus for the industry for a long time. Let's dive into what standard should we hold AI to? Like, what should we hold them to? Harm, do you want to?
Yes, it's a topic dear to my heart, and I've been involved in developing standards for AI systems for the last 4 years. There was a great deal of talk this morning about regulation, legislation, and what have you. At the same time, as desire for regulation increases, the recognition also is that regulation will lag, and standards have a role to effectively fill that gap in time to assure the public, to assure organizations that AI is being used responsibly, as you mentioned it. So 2 standards that I'd like to bring to everyone's attention here are ISO 42001. And for those that are familiar with cyber, you probably have come across ISO 27001 for security purposes. A similar standard is being developed, and it basically outlines a whole range of good practices that organizations can commit themselves to incorporate in their day-to-day operations, which will bring you very, very close to that responsible use of AI. There are some standards emerging, particularly around areas of risk. At the same time, there is a limitation to most risk-based approaches, and that they tend to be fairly insular to the organization. So organizations, when they think about risk, they think about the risk to themselves. And of course, the general public is very concerned about the impact that AI might have on their day-to-day lives. So a separate emerging standard is ISO 42005, and it is such an impact assessment standard. So coming to you towards the end of this year.
So moving to Gulshan, from your perspective.
So I think following on from what Harm said, I think it ties in the main standard that we're all kind of held accountable to and that we have to meet is community expectations. So while investment is growing globally in AI, in Australia adoption's relatively low. So if we're not meeting those community expectations, people won't use AI or they won't want us to use AI. So we've got very comprehensive, robust governance processes in place, but we're continually reviewing those as the technology evolves, and also to understand and keep in touch with those community expectations. We consult externally, so with the Gradient Institute and CSRO, so we're always meeting those community expectations.
Thank you. And moving back a bit more to, I guess, the use case. I think when we discussed this earlier, Nick, you had an interesting point of view in terms of the standards, depending on what it is.
Yeah, that's right. It was just kind of like a nice little, I guess, thought experiment that hopefully stays a thought experiment around kind of the standards we hold AI to. So I've, talked to people about AI a lot, and everyone's got their own opinions, obviously. One of the big ones I've heard come up a lot before is around self-driving cars. So a common argument is, well, there's tons of accidents on the road anyway. People are not faultless drivers by any stretch of the imagination. There's a high fatality rate, so isn't the standard we just hold AI to just as long as it does better than people, then we should just implement it and have everyone in self-driving cars? And I'm not necessarily saying this is wrong, but there's kind of ramifications that maybe people don't think about when they make decisions like this. And one of them is the ability to influence things en masse. And the probabilities of people are more or less randomly distributed, but that's not the case for AI. So what I mean by that in a practical sense is, if every person, let's say, has 0.25% chance of having an accident every time they go out in a car, it's not quite that high, thankfully, and you create an AI that has 0.1%, so significantly less than that, it doesn't necessarily mean that things are going to be better. What could happen is, say there's a bug in the system, and it affects all Teslas, let's say, and that's the only AI car on the road. If that bug happens, it doesn't happen, it doesn't happen to that percentage of people, it happens to everyone. So there's a 0.1% chance of every Tesla crashing in that same way. So the damage is almost multiplied out, and you have to have society safeguards that if that sort of thing occurred, you wouldn't have mass breakdown and certain things that cause greater effects than just every day 0.25% of people dying randomly on the road.
Yeah, Flora.
Just one comment. I think we all want to make sure the system that we deploy will continually to be reliable, right? But the thing is, a lot of the AI models are trained offline, and when there are new unseen scenarios, even during COVID, when we had the first lockdown, a lot of systems predictive AI systems in fintech stock market, they crash because they haven't seen it before. So there are, of course, ways to make sure that machine learning model will continually learn. So there's continual learning mechanism. Also because in deep networks, there's what we call catastrophic forgetting. They tend to forget patterns they have not seen for a long time. So, so it is important to make sure in one of the standards, the AI system that are deployed continue to work and robust. They don't go stale, and machines need to learn to remember, but also machines need to learn to forget. Because in things like GDPR, for example, we know in a lot of examples in the past, right, data breach. You know, and someone complained, I'm no longer a customer of such and such company for more than 10 years, but why do I get an impact of the data breach? So machines need to also forget that person's training data if they ought to.
Thank you very much. I think we've run out of time. If you have questions to the panel, please seek out them after this session. We're happy to stay and answer questions. Yeah, so AI is obviously flourishing in our industry and will continue to do so. Hopefully, all of you creating a bit robust models with less unwanted bias and yeah, take us to the future. Thank you. Thank you, the panel.